Alright, I'm going to show you how I set a game up without using my cart. When I do deliveries, obviously I don't always have my cart with me, so I set them up like this. Put the legs on like this. There we go. Lay them down. Yep. And then I bring the front down like this. And bring the back up like this. And then I put the back legs on. It's easier with the cart, but it's not too bad doing it this way. This one's going to be out of camera, but you get the point. And on these older solid state games, one of the early solid state games, the heads come right off, whereas the newer ones, they hinge down. So these are a little bit easier to move because they're lighter, but you got to hook all the cables up too, which is the downside. Definitely easier to deliver down a staircase though. Don't forget to take the cord out. And then for the head, slide the glass up. I'll just take the glass out of the way. And then we put it on. And then we'll do a close-up here for the rest of the head. And yeah, not too bad, no cart needed. All right, on this one, once you get the head set up, placed on top, you got to put these 4 bolts in. So it's a little hard to line the bolt holes up, but you just kind of have to wiggle the head around until they line up. Kind of wiggle it, get them in there. And tighten them down. All right, now we got this is a Williams. So Williams System 3 to System 7 has all these plugs here. So you got to hook the plugs up, but they're all kind of keyed, so can't really plug them in wrong unless you're really trying to. So you got to dig the harness out. Find all the plugs. There we go. Plugs. Here. Yeah, this particular game is a Williams System 3, which is the first system of digital games that Williams did after converting from electromechanical. These came out in, I think, 1976. maybe 77, I don't know. Anyways, get all the plugs in. And I think we got them all. That's it. That's setting the game up. Of course, we still have to make sure it works, but at least it's set up now. All right, so as always with these digital games, you gotta check the batteries. In this case, batteries are not very good. See, they had corroded. And fortunately in this case, and I'm going to do a close-up here in a minute. Fortunately in this case, the batteries had only alkaline, battery acid some people call it, but it's not technically an acid, so you're supposed to say alkaline. They didn't take out the board in this case, just the battery holder. So let's do a close-up here. So what happens is the acid drips down from the batteries and gets on these chips, takes the sockets out, takes the chip out. If it's not that bad, you can put a new socket in, you can replace the chip, and you can get the board going. But sometimes it takes this connector out, and it starts getting into these transistors, and just it can get real bad. And at that point, you should probably just replace the board. Fortunately, in this case, we only have minor damage. So let me go up a little bit here. There we go. So what do? I don't know. You ask 10 people how to do this, you're going to get 10 different answers. A lot of people say only do NVRAM, which is a non-volatile RAM. It removes the need for the batteries altogether, but that's a good option. But in this case, I'm going to put a different battery holder on. So I suppose I could show you both ways, but for now we're going to do a different battery holder. So you can really just clip these off here. There you go, battery holder's off. So now with the battery holder, you get one side that's the red, the hot, and the one side that's the black. And how do you know which is which? Well, it can be tricky, but in this case, let's zoom in here. It's obvious in this case once you take a look at it. All right, so even from the front of the board, you can kind of see that this is the hot, and that goes to a diode. That's so that the game can't charge the batteries because they're designed for non-chargeable. The diode prevents the current from going from the game to the batteries and only lets the current go from the batteries to the game, in which case you don't charge the batteries. But you can also see these little diagonal wires here. And that's on the back of the board, but you can kind of see through. So what happens is power goes from here through the battery to here, through the lead, through the board back to here, through the battery to here, through the board back to here, and then through the battery to here, and then this is ground. See, this whole big metal thing goes right to here. So if we solder, see, that's all corroded. It can be hard to get a good solder connection when you get that kind of corrosion, but we can really solder to anywhere that's ground for the black wire. And then for the red wire, which is hot, we could solder to here, but if this had corrosion, we could also solder to here, and either one would be fine. All right, let's install the battery holder. All right, so I like to use this. It's called a fiberglass brush pen. Oh, over here, fiberglass brush pen. You can buy them on Amazon. They are fiberglass, and it really cleans corroded stuff. So we could try to clean this off to see if we can get a good connection to it. But what I'd really like to do is just do right here. So I'm going to clean a spot off here so I can get a nice solder ground. And then this one's already nice and clean, so I don't need to do there. So I'm going to burger up some solder and try to do this here best I can without blocking the video. Burger up some solder here. That's enough. You get some right here. All right, we got solder. So I have these battery holders. They're just a button cell battery holder with 2 wires that come out. I got a box of like 1,000 of them. I'm not exactly sure where they came from because they were already here when I took the shop over. But there's a lot of different options for these battery holders. This is just the one that I've been using. It's got a standard. The good thing about these button cells, these button cell batteries, they're only lithium, and lithium doesn't leak, unlike alkaline. So the good thing about this is you can never put an alkaline battery in there. So if somebody down the road gets the game, you don't have to worry about them putting alkaline in there and taking the board out. Oh, that is in there. Battery holder is there. All right, so you just put the battery holder in. Let's make sure that we have power. One of these little button cell batteries, it should be about 3.2 or so volts. If you got volts, then you're good. So let's see if we got volts. You can put the ground anywhere because remember that's the whole ground. And then so it should be volts here. Should also be volts here up to the diode. And then it should be volts on the other side of the diode, but a little bit less. They call that the voltage drop. So when volts go through a diode, one way they go through, but they drop just a hair, and then the other way they don't go through at all. So there you go. So I got the ground, I got the volts here, and I got a little bit of volts here with the voltage drop. So I know for sure that we have power now and we're good. But what if I don't want to do a battery? What if I want to do an NVRAM? Well, that's an option too. So how do we do that? Well, I can show you. So I got to get my chip puller, which is what I'm looking for right now. I should have had it handy, but I didn't. So, all right. Let's get into NVRAMs here. So here's an NVRAM. There's a guy, there's a lot of NVRAMs. A lot of people make them, but there's a guy on the Pinball forum that was selling these. I bought 20 of them from him. I got these ones. This is 5101. This is going to be for your early first gen System 3 through 7 Williams games. Also, the first generation of Bally and Stern solid state games. And in this particular case, all these games you don't actually have to solder the chip in because it's already socketed. Whereas later games, the chips are socketed, so you have to remove the board. You got to remove the chip. Chips are not socketed. You got to remove the chip. You got to put a socket in, and then you got to put the RAM in, which is much more work. But really anyone can do this. DIYer could do this, no problem. So I'm going to zoom in on the chip, and I know you can't tell right now which one it is, but I'm going to show you. It's this one, right? But how do I know which way it goes? Let me get a better look here. So these chips are marked. I'm going to go show you here real quick, see if we can see it. They're marked. See, there's like a little thing here at the bottom, and all of these have that. That shows you which direction the chip goes in a socket. So this has a picture just for reference that shows the little bump there at the bottom, and this shows a little bump at the bottom. So that means it goes in this way, not that way, because that way the bump would be here, but it's not, it's here. Bump's right there. So we know the chip needs to go in this way. All right, we got that figured out. Important, don't put it in backwards because it just won't work. I don't know if it's going to break the chip or not, but it definitely won't work. All right, here we go. So we pry this one out super carefully. I use call this my chip puller, just a screwdriver that has been bent. Chip puller, very useful tool. Let's pull a chip. You want to be a little careful, of course. You know, these are somewhat delicate. Of course, it doesn't really matter if you mess the old RAM up because you're not reusing it. But still, when you're pulling a chip, you want to be careful. Do a little bit on each side, get it out like that, nice and clean. And then let's put the NVRAM in. So I should clarify, you do one or the other. You don't do both. I'm doing both here for the sake of this video. But normally, I should make that very clear. You don't do both. You do one or the other. You push this in. And that's it. Then you got the NVRAM. Now you can take this battery holder out. You don't need it. In this case, I'm going to leave the battery holder in because I already put it in. And the battery, honestly, it's good enough to, not good enough. Someone said, don't say good enough, just good. The batteries are good. You know, they hold up a long time. And as long as it's not double A's that are going to leak on you, the battery is fine if you use a remote holder. NVRAMs, they cost about $25 each. So if you're doing a lot of games, that can add up. But batteries are fine. Or a battery is like $3 or $4, and the holders are not very much. Plus, I got a box full of them. So I like to use the batteries. That's what I did this time. But you can make that decision for yourself on your game. Okay, anytime that you change the battery or that the battery dies, you turn the game on. It starts up with this little error message here. Up in this one, and the other ones work. It's very easy to clear, but a lot of people call me just because of this error message, and I try to walk them through it over the phone because it's super easy to clear, and it happens every time you do a battery. So let's turn the game on and see what it says. Toggle switch down here. Well, this is doing something different, okay? So this seems to be stuck in some kind of test mode because it's, so 4 down here means you're in audits and adjustments as opposed to diagnostics. And this is scrolling through the numbers. So that tells me that maybe there's a stuck switch to get into audits and adjustments. But this isn't what it normally does when your battery dies. So we got a whole nother problem. Let's see what's going on here. Yep, it's not what I was expecting. So we're going to go ahead and figure this out. It's just scrolling through audits and adjustments. All right, I got the key in here now. So let's see what we're doing. We're going to push some buttons, open the coin door. These buttons. Huh. Well, I just pushed some buttons and it found its way out of that little circle it was in. A lot of times that's all it is. You just kind of play with these buttons. I didn't really have any game plan there. I was just moving these switches and I held this button down and I was moving this switch and I pushed these buttons a bunch. And then it fixed itself. And a lot of times you turn it off, you turn it back on real quick, like that, and it kind of fixes itself. All right, what else are we going to do here? Let's see if it starts the game. No. Oh, it did that time. It's got no ball in it. That's part of the problem. It's hard to play pinball without a pinball. Of course, this game needs to be shopped out. So we're just going to put the ball in here to see. All right, so the ball came down here and didn't drain. And we're going to figure it out. Oh. Seem to have some stuck switch issues. Oh, it game overed on me. What does that mean? Well, let's go to switch test. See if we can figure that out. Well, that's audits and adjustments again. All right, I'm gonna try to figure this out here. And what's happening? Sometimes these games just have a bit of a personality. Let me figure this out and I'll be right back. So cold solders is a big problem on these games. I've seen cold solders on the power supply do some weird things to the MPU board. The MPU board is the logic board. So I'm going to go ahead and actually I already did and I already found them. So you should check. This is the power supply board here. When you're going through one of these, it's a good idea to check your power supply board for cold solders. So I'm going to show you how to do that here. You got to take it out to do that, of course. So we're going to take it out. We're going to put it on the bench here. We're going to zoom in on it. We're going to take a look at our cold solders. And we're going to find them. And so first, it's good to understand this power supply a little bit. So I got the manual here. So this plug here is actually where the power comes into the power supply from the transformer. So you want to make sure that's making a good connection or else the power supply won't read voltages at all. These connectors here are not going to prevent you from a game from booting. They aren't going to have any logical issues. These are lamps up here, so these ones are going to be lamps. And then these are solenoids. So once the game boots up, and logically it all seems fine, and if you have lamp and solenoid issues, it could be here, but that's not a problem. So when you first check a power supply for voltages, assuming it's getting a good connection here from the transformer, you check up here. So those ones are very important for the logic because that goes right to the MPU. So see here we got these first ones here are ground. And these are going to be black wires in the connector. These ones here are 5. Those are gray in the connector. And then this one here is unregulated 5 volts. That one's going to be, so unregulated means it doesn't go through the voltage regulator, which, so 5 volts has to be super steady, exactly 5 volts and consistent, because that's like the heartbeat of the game. So if you got a 5 volts that's not consistent, it won't work properly, and the voltage regulator makes sure you got a steady 5 volts. Anyways, so these are kind of the connectors that, assuming power is getting in okay, these are the connectors we're going to look at for power going out to the MPU, which are these ones. So let's put this board on my desk and see what we can figure out about the cold solders. Okay, here's the board. So we're going to look at these connectors, and we're going to look at this connector specifically, this one too. The other ones are important too. We're going to look at all of them. So let's take a zoom in here. Zoom in. So here are the top ones that we were talking about that the power goes out of the power supply with. So let's see what we can see here. I can definitely see that one has cold solder, but see it doesn't go to anything, so that one's not really important. But over here, these are the ground. Remember, these are the ground ones? Let me get the manual out here again so we can have a good reference. So these ones here are these ones here that say ground. See how they all go to the same trace? So they all do the same thing, but they got massive cold solders. So like that one's not making a connection at all. That's what a cold solder looks like. The solder just kind of breaks down around the pin, and then it no longer makes a good connection with the pin, and you got to reflow them. So they're not all bad, but definitely some very bad ones. So here's the input. Remember, this connector here is this connector here, very important. So these ones can be a little less obvious, but they're often there, but they're not always as obvious. So I think that one. Can you zoom in on that one? Oh yeah, look at that. That's nasty. See, it's kind of hard to tell from a distance, but if you really look at it, you can see that the solder just doesn't look like it's making a very good connection to that pin, and that'll cause you some problems, definitely. We're gonna do them all, but I definitely see a few that look questionable. And then what about here? These ones aren't our current problem, but we want to prevent problems while we're here. Here's one. See that one there? Oh, I lost it. So yeah, definitely we're just going to do them all. Let's do it. So when I do cold solders, I like to have my fan because it blows the smoke away from me. I got this off Amazon. It's cool, just a little fan with a little filter on it to blow the solder smoke away. Turn that on. And I got my soldering iron right here. And then we're going to get to work. Okay, I got the power supply all plugged back in now. And I want to show you, I did this earlier, but I didn't show it on the camera, so I'm going to show you now. How do you test one of these power supplies to make sure your power supply is putting out the proper voltage? So all you need is to have this and this plugged in. Everything else you can leave unplugged when you're testing the power supply. All you're doing is testing the board. You're essentially making sure the board is taking in the proper voltages and converting them to 5 volts. And then there's the 12 volts and the high voltage. But you really need to make sure the 5 volts is the most important for whether the game boots or not. Then you got the unregulated and unregulated 5 volts, which is usually around 12 volts. I don't know why it calls it that. If you know, you can put the answer in the comments. But yeah, you'd expect this to be around 12. And then 100 plus and minus 100 volts, that's for the displays. You want to make sure that you got that, but we already know the displays are working fine, so I can tell you right now that's working. And then there's another ground. So all the grounds here are black. All these 5 volts are gray. That one's gray with a white stripe, and these are different colors. But we're going to go ahead and test them. So we're going to plug these in, we're going to turn the game on, and we're going to test these. Let's do it. See if we can get a good picture here. I'm going to cut it so I can get the multimeter in the screen as well. All right, I'm going to go ahead and use a clip lead here for the ground. Make it a little easier. I know this first one's ground, because remember, first bunch of ones are all ground. So, turn the game on. Plug it in. There we go. All right, so these first ones are all still going to be ground. You do want to be careful because you don't want to short. See, that's 5.17. That's good. That's a solid. That's 5. You don't want to short the ground to the 5. So you do want to make sure you're only touching one at a time, which is another reason I used a lead. See, that's the unregulated one. It should be around 5, but that one doesn't need to be around 12. Sorry, that one doesn't need to be exactly 12, but it should come in at around 12. And these ones, I think in this particular game, these are not used. Oh yeah, see, there's nothing here. So now we get to there's the other 5 for this plug. Now we should have positive and negative 100. I got to change my meter. Here we got positive 100. We got negative 100. We got ground, right? So that's what it said here. See if I can show you here. So we just tested all this, right? We tested with one clip on ground, tested to make sure those were all ground, and then we got to the 5 volts. Like I said, you don't want to short the 5 volts to the ground, so you got to be careful not to touch those 2 leads at the same time. Made sure all those are 5 volts are coming in strong. We made sure the unregulated, which is supposed to be around 12, but it can vary from like 10 to 13. I don't know, it doesn't seem to matter that much. Here's another 5, which we had. And then we got the positive 100. It shows here positive 100, negative 100, and ground. So the power supply is good. We know for sure power supply is good. So the game's still doing weird things. Let's try to start a game. It's not supposed to do that. It's kind of crashing and not working, and it's not happy. So I think there's a problem with the main board. So we're going to take the main board out and we're going to take a look at it. That's going to be, oh, see, it's doing that again. I don't know, man. This thing's just confused. Let's take a look at this board. So this is the main board. This is the MPU and this is the driver board, but in this case they kind of act together as one. You kind of think of this as one board, even though they're 2 boards. But we're going to go through them. Let's see what we can figure out. So I got both these boards off here, and I don't see any cold solders on them. Doesn't necessarily mean they're not there, but I don't think that's my problem because I don't see any obvious ones. So the next thing I'm going to try is to clean these chips, remove these chips one at a time and clean them. So this is on this particular game, this is the MPU and this is the driver board, but they sit in together like that. And actually at the time, the circuit boards couldn't make a big enough circuit board to incorporate all what the MPU needed. So the MPU does rely on these 3 chips to boot the game. So in this particular case, it could be either board. But I'm going to start with this one. I'm going to clean the chips, and we're going to cross our fingers on that one. I have to say none of those were super bad looking. So I'm not extremely optimistic, but we're going to plug it all back in. And we're going to see if we fixed it. Let's find out. Oh yeah, right, this one. This one goes in second. And I will put all the screws back in, but for now I'm just testing it. So I'm going to stick with these 4. Plugs back in. And the manual says exactly what every one of these plugs does. But that's for troubleshooting down the line. Right now we're just trying to get it to boot properly and not crash, which is the higher up problems. I got this one stuck. All right, we're going to plug it in, and we're going to see what happens. It's doing the exact same thing. All right. So my next thought is maybe some alkaline dripped onto this socket. I did see a tiny little bit of evidence that that might be the case. So I'm going to have to replace this socket, possibly this one, and we're going to see if that fixes it. All right. All right, here we go. So of course we're going to have to pull the chips again. See what we can do here. When I do a socket, I like to put fresh solder on all the tabs before I try to suck the solder out, because that makes sure it's all nice fresh solder. That's going to it's going to come out easier. So I have this this solder removal gun, desoldering gun. Works pretty good. Well, it's pretty self-explanatory. I'm gonna try to get the solder out now. All right, it took me a minute, but I got everything back together. So I put new sockets in this one and this one and in that one because I thought maybe the battery acid got in there a little bit. And well, it's working now. All right, see, we're up. You can add credits. Yeah, I didn't do that before. We start a game. Juice the ball out. Flippers work. None of these are work. Oh, that one worked. All right, you got to hit them in order. Well, these just aren't working here. A little bit of tweaking still. Oh, no, they're working. Look at that. I think we got it. All right, it's working. That one was a little difficult, I'm not going to lie. But it's working. So what do we got to do now? Well, we got to shop it out. How do we do that? Let's see. We're going to shop it out now. All right, so for this one, we set it up. We dealt with the battery. Either you can install a remote battery or you can install an NVRAM. We did the cold solders on the power supply. We checked for cold solders on the MPU board and the driver board. We had to replace 2 sockets and a chip on the driver board because of battery corrosion. And we got the game to boot up. That's usually the hardest part. I think that's enough for this video. It's getting kind of long. I don't want to bore you guys. So the next video is going to be shopping this game out. When I shop a game out, I clean the leaf switches. I make sure the sensitivity is good. I clean and wax the playfield, replace all the rubber rings. I roll the ball around, make sure the targets have the right sensitivity. So that's something to look forward to for the next video.